Hello everyone. In this video we will talk about the design and method of operation of two main kinds of shift registers, bidirectional shift registers and universal shift registers. So let's first begin with bidirectional. So what is a bidirectional shift register? Now see, shifting a binary number to the left by one position is the same as multiplying the original number by 2. And this again, I think, is something that you have already covered in your syllabus so far, right? So when we say that we want to shift a binary number to the left, it's the same as multiplying that number, which is why in electronic circuits and in computers, multiplication and division is performed using shifting. It's a much more efficient and less expensive method of performing multiplication. So instead of actually, multiplying a binary number with another binary number, it's easier to just shift the number because it gives you the same results, right? So if you had a number, for instance, 0110, which is the equivalent to 6, right? And say you shift this number to the left by one position. So what do you get? By shifting 0110 to the left, you get 110, and another 0 moves in because now you have nothing for the fourth position. So this goes here, this goes here, this goes here, and a 0 is entered. And what is this? This is 12. So by shifting a binary number to the left by one position, you have essentially multiplied that number by 2, right? And the same goes for division as well. Shifting a binary number to the right by one position is the same as dividing that number by 2. We can take the same example. We had 6. If we shifted this to the right, shifted each bit to the right by one position, you get 0011. And what is that? This is 3. 6 divided by 2, right? So if we want to use the shift register for multiplication and division, because you already know that shift registers are used in calculators and computers to perform mathematical computations, right? So they're very handy when it comes to addition and subtraction. So if we wanted to use the same arrangement of shift registers to perform multiplication and division, so instead of actually multiplying any number by the other number or dividing the numbers, we can just shift them by the necessary amount of bit positions, right? So if we wanted to use shift registers to perform multiplication and division, then we should be able to move the data in either left or right directions. And that's all you need your register to do, just to shift the data either to the left to simulate multiplication or to the right, which is equivalent to division. And that is why we need bidirectional shift registers. We just want our registers to have this additional capability of being able to shift our data in either directions. If we wanted to perform multiplication, the same setup should be able to perform left shift. And if we wanted to perform division, then the same setup should be able to perform right shift. So usually the registers that we have discussed so far, SISO, SIPO, PISO, PIPO, they are designed to shift data in only one direction, right? Okay, let's take a quick look back. So either we design this or we design this, right? So a register that shifts data to the right cannot shift data to the left. You have to design this in a separate manner, right? So if the data is moving in like this and it's moving to the right, this register is not going to be able to shift the data to the left, right? And these are unidirectional shift registers. They have been designed to shift data in one direction alone. If you wanted to work in both ways, then you have to use a bidirectional shift register. This is the same register, but you can control if it moves your data to the left or the right. Okay, so you need some kind of additional circuit that would make that kind of switching possible. And this is how it looks like. This is a basic 4-bit bidirectional shift register, and you can see that with the addition of a few more lines and a few more gates, you can actually achieve flow of data in either directions, whatever you wish. The basic setup is the same. Again, you have 4 flip-flops, right? You have the clock. This has to be there. Simultaneous clock pulses need to be applied to all of the flip-flops. Uh, In addition to that, we have a serial data input line. Again, like we used to in the previous cases, we have an output line also. What's interesting is this part, the a control line that decides the mode of operation of your register. So you can pick whether you want the data to move to the right or you want the data to move to the left. And that is achieved by this line, which is controlled by all of these gates. We have the NOT gate, we have AND gate, and we have OR gates. So let's take a look at how it actually works, because that would help. So the design is fine, but the operation part is important. So again, this is a bidirectional shift register. The only two operations it performs is either it shifts the data to the right or it shifts the data to the left. So these are the two operations we are going to be discussing. So let's first start with the shift right operation. Oh, sorry, this is a terrible line. Shift right operation. This happens when your right left line is 1. And you can see these are the complements of one another. So if one goes high, the other goes low. That's how it works, right? So this line, when this line is 1, your register is going to be operating in the shift right mode. What happens in this mode? When this line is 1, the AND gates G1, G2, G3 and G4. G1, G2, G3 and G4 are enabled, which means they are active, which means they will be behaving like open circuits, right? So these 4 registers will be open. The other 4 AND gates will be closed. Data will be shifted to the right bit by bit, right, on the application of the clock pulses. Because, see, this is open, so data can just move here. Okay, data can just move here, and then from this flip-flop it will move to this flip-flop, and then from this flip-flop it will move on to this one. Shifting right, this is what's happening. Data is being shifted from left to right, one bit at a time, upon the applications of the clock pulses. And then the other mode is when this line is low, 0, right? Now when this is 0, G1, G2, G3 and G4 will shut down, they will be disabled. Instead, G5, G6, G7 and G8 will be open. These 4 will be opened, right? And when that happens, data will be shifted bit by bit from right to left this time, right? Because these gates are shut down, but these ones are open. So see now, the data can simply, whatever bit was in this flip-flop, because this is a feedback network, right? So you can just move on. G7 is open. It'll just move on here. Whatever bit was in this position can simply pass through this flip-flop, go to this point. Whatever bit was this position will go from G5 to this position. And what have we done? We basically just shifted the data from right to left. We're going back now using the same circuit. The only thing that decides the direction of the movement is this line, this one. So this is how a bidirectional shift register operates. By controlling whether this line is high or low, you can control the movement, the direction of the data flow. All right. And again, all of this will be controlled by the clock, right? So the gates are open and they are allowing bits to pass through them, but the actual passage of the bits will be controlled by the clock pulses. So the bits will only move and loaded into the registers when the clock dictates it. Right. Now let's talk about universal shift registers. Right. So this you can understand by now that a shift register that can shift the data in only one direction is called a unidirectional shift register. A register that can shift the data in both directions, like we just discussed, is a bidirectional shift register. Right. A shift register that can shift the data in both directions as well as load it parallelly is known as a universal shift register. So what this means is a universal shift register is capable of performing the following 3 operations: left shifting and right shifting like a regular bidirectional shift register, with the additional capability of parallel loading. That is, the bits can be loaded into a universal shift register all at the same time. So if you have a shift register that enables you to do all of these 3 things at the same time, right? With control circuit, naturally you'll have to have a proper control circuit in place. Then that is called a universal shift register. In other words, you can say that if you have an additional capability of parallel loading in a bidirectional shift register, then that becomes a universal shift register. And this is what it looks like. This is the design and operation of a universal shift register. This time, uh, we have designed it using R and S flip flops. So even though so far we have only seen all the illustrations were using D flip flops, that doesn't mean that you can only use D flip flops, right? You can use all kinds of flip flops. So, for instance, you can see that in this case they have designed it using R and S flip flop. So we have the 4 flip flops because this is a 4-bit universal shift register. We have the capability of parallel output, we have the capability of parallel input, right? And because of all of these gates, arrangement of all of these gates, you can control the direction of data flow from left to right, or you can do it right to left. Plus you can have additional capability of parallel input, and all of that is controlled with your mode control line, your M. Okay, we have 2 clocks this time, one that will control the right shift operation and one that will control the left shift operation. All right, now see how it works is the mode control input, this M, is connected to logic 1 for parallel loading operation. That is, it when it is 1, this universal shift register will perform parallel loading, right? And when it is 0, this register will perform serial shifting. All right, with the mode control pin connected to ground, the universal shift register acts as a bidirectional register, right? This is the same setup as a bidirectional shift register. If you just put it to the ground, this entire thing will start to behave like a normal bidirectional register. That is, all of this except the parallel loading part, right? And then for serial left operation, if you want to shift the data uh, to the left, the input is applied to the serial input, which goes to AND gate 1, this one, right? For the shift right operation, serial input is applied to the D input, this one, right? For the left operation, this is the input. For the right operation, this is the input. And that is the entire design and operation. So we need not go into any more details because otherwise it becomes very elaborate. That's beyond the scope of this lecture. So this is all you need to basically get a very basic overview of how universal shift registers work. Alright, here is an alternate design and operation of a universal shift register. Like we discussed earlier, it's not necessary that you have to design a certain circuit in a certain way. So here we use a combination of gates. Here we are using multiplexes. The end result will be the same. Both of these are universal shift registers. They perform the same functionality. It's just what components you use to design them. That's the only difference. Now, what happens in this case? So, if this is how we have chosen to design our universal shift register, this is the function table for this circuit, right? In this case, you can see we have 2 mode control lines. We have 2 select lines. Again, I'm sure you've already studied what multiplexes are. So multiplexes need selection lines, right? So this is a 4 by 1 multiplexer, so you need 2 selection lines, and these are those 2 selection lines. And in this case, in this setup, these S1 and S0 actually control the operation of the entire setup. When S1 and S0 are both 0, there is no change in the register. Nothing happens. When S1 is 0 and S0 is 1, this will behave in this will perform a shift right operation. Okay. When S1 is 1 but S0 is 0, then it will perform a shift left operation. And when both these selection lines are 1, it will perform parallel load. So these are basically the same operations that were being performed here as well. It's just a matter of how you choose to control these operations. All you have to understand at this point is a universal shift register is capable of doing 3 things: left shift of the data, right shift of the data, and parallel loading. So all you need now is control circuits that can actually let you switch between left shifting and right shifting and parallel loading. right? In this case, we did it using mode control and these circuits and these circuits. And in this case, you can control it using this, because the rest of the setup, you can see, rest of the setup is the same. Now, with the help of this diagram, I'll actually explain another concept which we haven't gotten into the details of till this point, which is the clear line. So what this clear line does is, it just makes all the bits zero. It clears all the flip-flops in a register. So if you can just activate this one line, it will make all the bits zero. That's all it does, right? Clear line is used to clear all the bits, whatever was stored in your register. So the register then goes back to zero, right? Just it's a fresh register ready to receive input. All right, so that's it for this video. And in this one, we talked about bidirectional shift registers and universal shift registers. So we discussed the design and methods of operation of each of these kinds of shift registers.